Hello and welcome back to Math Class in Session. Primary trig ratios, primary trigonometric ratios, parts of a right angle triangle. Yes, right angle triangles have parts. This is a right angle triangle, and we focus on one of the two acute angles, and we call that angle of focus the argument. So there's always one that we're focusing on out of these two acute angles, and the other angle is a right angle. These are the parts. And across from this right angle is the hypotenuse. And opposite the argument is the opposite side. And beside the argument is a side that we call the adjacent side. Now, because as long as the argument or the size of the argument stays constant, the ratio between the sides of a right angle triangle will also remain constant, no matter what the size of that triangle is. So, because of that fact, they've given the ratios between the sides names. So we have an argument, an opposite side, a hypotenuse, and an adjacent side, and the ratios are the fractions formed by putting the opposite and the hypotenuse, for example, into the numerator and the denominator position of a fraction. And so when it's opposite over hypotenuse, we call that the sine of A. It's actually S-I-N-E, but short form S-I-N, sine A. And when it's adjacent over hypotenuse, we call that the cosine of A. And when it's opposite over adjacent, that fraction formed by taking the opposite side over the adjacent side, that's called the tangent of A, or tan A for short. And we've got the silly word that helps us to remember all of this information. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And this silly word so katoa can be used to help remember the information about the ratios and the sides. Here's an example of a right angle triangle where the argument is up here by B. So this is our angle of the moment, our angle of focus. And so across from this argument, we have the opposite side. Across from the right angle, we have the hypotenuse. And beside the angle of focus, beside the argument, we have the adjacent side. Now, thinking so katoa, we can state the sine and the cos and the tan of this argument B. Sine of B is opposite over hypotenuse. We think opposite or across from B over hypotenuse. It forms a fraction. And that fraction is associated with the size of the angle B. The cosine of B, adjacent over hypotenuse, tangent of B, opposite over adjacent. Using a calculator to determine the following ratios. Okay, in this example, we're given 21 degrees and asked for the sine of it. So the sine of 21 on a calculator, confirm this for yourself. Don't take my word for it. The sine of 21 is 0.3584. And the cosine of 53, confirm it on your own calculator, is 0.6018. The reason I say confirm it on your calculator is because calculators can be in different modes. They could be in radian mode. So you want to make sure you're in the right mode every time you use your calculator. Tangent of 72, 3.0777. Confirm that. Let's try a different style of example. In this type of question, we're given the sine and asked for the angle. This is where we'll need our inverse function. Because instead of given an angle and asked for the sine, we're given the sine of an angle and asked for what is the angle. So remember, if you seek an angle, use inverse function. And here we're asked for angle A, so we'll need our inverse function. Angle A is the inverse sine function of 0.4142, and on a calculator that turns out to be 24 degrees. Here we're asked for the angle B, whose cosine is 0.6820. So if you seek an angle, use inverse function. Angle B is the inverse cosine of 0.6820, and that turns out to be 47 degrees. Notice the algebra. Sin moved across this equal sign and became sin with a little -1 on it. In other words, the inverse sine function. Similarly here, the cos of B, the cos part moved across the equal sign and became inverse cos. And the same will happen with tangent. Tan will move across that equal sign and become inverse tangent of 1.5620. And this gives us the angle whose tangent is 1.5620. Confirm it on a calculator for yourself. If we were given the sine of A as a fraction, or if we got this off a diagram using opposite over hypotenuse, our strategy would be to divide it on a calculator, 7 divided by 12, and then take the inverse sine function. Similarly with cosine, if you see a fraction and you want to plug it into a calculator and get, say, an inverse cosine, perform division, 4 divided by 15, and then take the inverse cosine of that, and you'll get angle B. Confirm it all on a calculator, please. Tangent C is a fraction. Turn that fraction into a decimal, and tan will move across that equal sign and become inverse tangent. So C is the inverse tangent of 1.8750, which we know from the calculator to be 62 degrees. Here's an example of using trigonometry to solve for a side. Notice in diagrams, in general, vertices are named with uppercase letters, like P, Q, R are uppercase letters, and the corresponding lowercase letters are the sides across from them. So if this is uppercase Q, side Q is across from uppercase Q, and it's lowercase q. So this is side Q. It could be called side PR or RP, but it's usually called side Q. So what we do is we start naming the sides. We could call the 12 opposite, and we could call the Q adjacent, if 35 degrees was our argument, that is. And so tangent 35 is opposite over adjacent. We chose tangent because, looking back, the sides that are in play are opposite and adjacent are in play. And that means tangent, according to SOHCAHTOA. And then multiply both sides by Q, divide both sides by tan 35. Multiply by Q, divide both sides by tan 35. And Q turns out to be 17.1 centimeters. Confirm it on a calculator. Observe the algebra. If tangent 35 is 12 over Q and the unknown is on the bottom, the Q and the tan 35 traded places. Compare this third line to this first line. The Q and the tan 35 traded places. There are 3 reciprocal trig ratios. Consider the ratio sine, which we know is opposite over hypotenuse. The reciprocal of sine will be a sine turned upside down, and it has a name. It's called the cosecant. And the short form for the cosecant can't be COS because that already stands for something. It stands for cosine. So we use CSC, cusc, if you wish. And the sides will be the sine upside down. So instead of opposite over hypotenuse, it will be hypotenuse over opposite. Consider the cosine function. The reciprocal of the cosine is the secant function, and the short form will be sec. And of course, the sides will be the cosine upside down. So instead of adjacent over hypotenuse, it will be hypotenuse over adjacent. And finally, a tangent function. It has a reciprocal function called the cotangent function. The short form for it is cot, and the sides associated with it will be not opposite over adjacent, but adjacent over opposite. Chosha cow, if you prefer to have an acronym that helps you, like SOHCAHTOA. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. Chosha cow. Now, the purpose of this is to show you that the sine and the cosecant are mutually reciprocal. Sine is 1 over cosecant. Cosecant is 1 over sine. The cosine and the secant are mutually reciprocal. The cosine is 1 over the secant, while the secant is 1 over the cosine. And the tangent and cotangent are mutually reciprocal in the same way. Notice in each pair of mutually reciprocal trig ratios, CO turns up exactly once. Sine x, cosecant x. Co was present once. Cosine, secant x. Co is present once in the mutually reciprocal pair. Tangent and cotangent. Co turns up once. And this can be useful. This study of the reciprocal ratios comes in handy when we're simplifying expressions. Like secant x plus 2 over cosine x. Well, 2 over cosine x is 2 times 1 over cos. And if you observe this box here, 1 over cos is actually secant. So this is secant plus 2 more secants, which is 3 secant x. Evaluate with a calculator. Pick up your calculator and try this. Secant of 25. There shouldn't be a secant button on your calculator. Secant, we know, is 1 over cosine. So this will be 1 over cosine of 25. That you can do on your calculator if it's in degrees and get 1.1034. And let's do this with cosecant of 75. You have to know that that's 1 over the sine. So cosecant 75 is 1 over the sine of 75. And on a calculator, we find that's 1.0353. Cotangent 60 will be 1 over tangent 60. And that's going to be 0.5773. Let's try some of these. Here we're given the secant to be 1.3175 and asked for what angle A has a secant 1.3175. To do this problem, we recall, if you seek an angle, use the inverse. But we don't have an inverse secant button, so what we will do is we'll use the mutually reciprocal friend of secant, which is cosine. We'll say inverse cosine, but since we took the mutually reciprocal mate, we have to take the reciprocal. So it'll be inverse cosine of the reciprocal of 1.3175. And try that on a calculator and get 40.6 degrees. Cotangent of an angle is given as 0.6667. Again, we don't have a cotangent button, so we'll have to use our tangent button. And if you seek an angle, use the inverse. So it will be an inverse tangent. Because if you seek an angle, use inverse, and we don't have a cotangent, use its mutually reciprocal trig ratio, the tangent. So we'll take inverse tangent of, well, we'll need the reciprocal of this because, well, we took the mutually reciprocal trig ratio, so we have to take the reciprocal of the trig ratio. So angle B will be the inverse tangent of the reciprocal of 0.6667, and that's 56.3 degrees. Do it on a calculator and confirm it. Lastly, there's one for you to try on your own.